Good afternoon, everyone. Welcome to the class ECE341, the probability and stochastic process. Today we will keep working on the random variables. We already have two kinds of random variable, right? We know the discrete type and continuous type random variables, and today we keep working on them. So this is the ECE341. This is the 7th week, Monday's class. We consider random variable. Random variable x. Then we have two kinds. One is a discrete type. One is a continuous type. So for discrete type, the random variable will take some separate values, right? And for continuous type, x can have value in kind of intervals, right? Intervals. Then to describe these two, we have several functions. So the first function is CDF. CDF fx of x equal to the probability of capital X smaller than or equal to x, lowercase x. Okay. This definition works for both type. It works for both type. Both type. Right. Yeah, this one works for both type. And then we have PMF, the probability mass function. This is a Px of x equal to the probability of capital X equal to lowercase x. So this one only works for discrete type. For continuous type, yeah, you still can define this function, but this function will only give you a 0. Will only give 0, so we don't use it. Then for continuous type, we have another function. That is a PDF, probability density function, PDF. The name similar with the same with the kind of files, right? PDF file, document file. But here is a probability density function. Probability density function. We write it as fx, capital X here, then x. It is the derivative of fx of x. For take derivative according to x. Right. So we have this one. The meaning between these things, they are similar, right? Similar. I gave some graph to explain it. So for this one, I say so this is a fx of x, right? Looks like this. Then this place, if this is some xk, then this place, the value of this, like the jump, right? This is a steer. The steer, you're going up. Then this value, it is just the px at xk. In other words, this is the probability of capital X equal to xk. Right, we have this one. And for the fx, this one, it will be okay. Now CDF looks like this. Looks like this. This is a fx of x, the continuous type. The CDF looks like this, right? CDF. Then you can also consider, like from here to here, you can check the difference. You check the difference. Okay. Similar with this, here you have a steer, right? here you also have a distance. This distance, it is a probability of x between, I have two values. This is a x, I will say x, some x0 and x0 plus dirt. Alright, so this will be capital X. The value of capital X is between x0 and x0 plus dirt. Yeah, so this one. Okay, so this is the probability. This value is a probability. Similar with this is a probability of a single value for discrete type. And here, this is also kind of like a distance jumping up, right? Distance jumping up. This is probability of this part. This part. And then, what is density function? What is density function? Fx of x equal to this probability. Actually, this probability now equal to Fx of x0 plus dirt minus Fx of x0, right? And Fx is Fx of x0 plus dirt minus Fx of x0. This is the probability over dirt, and you want the dirt tend to be 0, the limit. This is the limit. Okay, so they are somehow similar, but this is density, right? This is density because you divide it by this. If you do not divide it, you will have the probability. That probability will be dirt. So dirt times Fx. So that is, I will say, the probability of x0 smaller than x and x smaller than x0 plus dirt. This will be dirt times Fx of x. If you want, you can also put dirt in the back. Alright, so we have this one. Okay, so here the probability is just this value. Here the probability is also this value. And in the continuous case, you can have density function by this one. Yeah, by this one. Alright. You take limit is just the derivative. This is just a derivative. Derivative gave you the slope, right? Give you the slope of this kind of ramp, right? When the derivative is larger, the value is larger, that means this increase faster, then the probability is larger. And here's a similar thing. If here is a large, this steers value here is larger, then the probability were large, right? Yeah. Okay, so these are the definition and the relation, and we can also have the probability of x between some a to b. This one here might be equal, might be not equal. I just put equal here. Alright, I put the not equal here. I put not equal to here. This is equal, this is not equal. This is most simple case. If here's equal, that's a different case. If here's not equal, that will be another different case. Alright, and if both not equal, that will be also a different case, right? Then here I just give this case. For this case, it will be Fx of b minus Fx a. It's just this one, and it is also, this is CDF, right? I can also write this probability in terms of mass function, probability mass function. By mass function, this will be a summation of px of lowercase x. Which kind of lowercase x? I do summation, right? I want for those x, lowercase x, its value is larger than a, smaller than b. Okay. You pick all the possible x between this A and B. Then you have a Px of x. You do summation, you get the probability. And okay, for continuous case, we have similar thing. We consider this A smaller than x, smaller than or equal to B. I use same thing. This will be, I still have this fx of B minus fx of A, right? This is same because CDF, no matter it's continuous or discrete type, CDF is always this one, capital X smaller than lowercase x. This is the event, the probability of this event. When you consider this interval, that means the large interval from negative infinity to B, you have this probability. And remove the another event is smaller than A, right? One event is smaller than B, the probability is this one. The other is capital X smaller than A, you need to remove it. Smaller than A part, you need to remove it. So you need to minus this. So you still have this. The same with this one. And then we can also use a density function to write it. Use density function. This will be an integration from A to B. This is a density function, PDF dx. Okay, that's it. Yeah, that's it. Now you compare here. Here's a summation for all the possible x between A and B. You have a lot of terms, you do summation. This one is an integral for all the x between A and B. You have this one, you do an integral. We know the integral actually it is a limit of a summation. Remember what is the integration? The definition, when we define what is the integral of a function, we represent it as a summation of some terms and make a limit, right? Then we have this one. So actually it is just this kind of things. So for discrete type you do summation, for continuous type you do integral. Alright, okay, this is one thing. Of course we have something different. The difference is here. For continuous type, here is equal or not equal, doesn't matter. If I change here to be equal, still be the same formula, nothing changed. But here, if I put the equal here, then this place you need, if I put equal here, this place you need to use some value smaller than A. You need a minus some delta. You put some delta here. You need to put some delta here. A minus delta. You need to replace A by A minus delta. That means you cannot remove A. A is here. A is here. You need to remove all the rest values, but not A. All the values smaller than A, you need to remove it. But you cannot remove the value A. So here you need to remove a little bit smaller than A. So A minus delta. Delta is a small number. Delta is a small number. Delta, small number, positive number. Right? Positive number. Okay. So these are the definition of random variables and the definition of CDF, PMF, and PDF, and the relation between them. All right. Now we consider some numbers. Actually, two important, not just two, some. Yeah. The most important number are two numbers, and other than that, we have more. That is, I say some average values. The first one is mean, or we say expectation of random variable x. Here we have two types, so we have two definitions. For discrete type, that expectation value, okay, people like to write it as EX or E of X. The E is expectation. EX will be a summation of all these xi times px of xi for all xi's. And for continuous type, Ex is integral of x times fx x dx. Here is a negative to positive infinity. So we have these two. This is definition. These are definition. Okay, first of all, you can compare what's the difference between these two. Here's xi and the px of xi, right? This discrete type. And here's x and fx of x. So they are similar, just to replace the mass function, probability mass function, by density function. Then you have the continuous one, right? So you different just the PMF or PDF. And here also we have different. This is a summation. This is integral, right? Okay, this is definition. Then what is the meaning of that? I say this is a mean value or expectation value. I use an example to explain it. I have x. This is discrete type random variable. It takes value 2 and 4 with probability each is half. So what will be the average value? You can take x. Sometimes you get 2. Sometimes you get 4. Then the average will be 1. They have equal probability, right? So like you have, for example, you take 100 samples. Take 100 samples. Then we have 2, 50. Number is 50, right? I have 4. I also have number 50, right? 50, you take 100 samples. Then 50 samples are 2, and another 50 samples are 4. So the mean just the normal meaning, right? People say, what is mean? Mean is a kind of, in the middle, right? So the mean will be 50 of 2 and another 50 of 4 over 100, right? This is the mean. And I can write in this way. Okay, so this is a probability. This is also probability of x equal to 2. This is a probability of x equal to 4. Right? You see, the value 2 times the probability of that 2. And here's the number 4 times the probability of x equal to 4. And do summation. And that will be mean. It is same with this. And this one, this is a normal meaning, normal way about of the mean, right? When we say mean of some numbers, it is just this one, right? Mean of some numbers. Okay, if we make some change, x, I still have 2 and 4 possible values. Yeah, but the probability, I have 20% 2 and 80% 4. Then what will be the mean? Okay, we use similar calculation, right? I still like to take 100 samples. Then I have 2, the number is 20, and 4, the number is 80, then the mean will be 20 times 2 plus 80 times 4 over 100. So that is a 0.2 times 2 and 0.8 times 4. Okay, similar thing. The value is 2, probability is 0.2. Value is 4, probability is 0.8. Then do summation. So the thing is like this one times this one, this one times this one, then do summation. That is a mean value. That is a mean value. All right. Okay. Yeah, if you want, you can find the final value. What is the mean? This is a half of 2, half of 4. So it is equal to half of 2, and half of 4. That is 3. Right? This is 3. So the mean, it will be a value between 2 and 4 is 3, just in the middle. And this one, there will be 0.4 plus what it is, 4, 8, 32, right? 3.2, this is a 3.6. Okay, so in the first case, they are equal likely possible, right? So the mean is just the number between 2 and 4 in the middle, right? 3 is a number between them in the middle, just in the middle. And this one, we have more chance to get 4. Then the mean value is a number a little bit closer to 4, right? It's close to 4. It's a 3.6. Right? The middle is 3. It's larger than 3, close to 4. Yeah, because we have more chance to get 4, right? 80 chance to get 4. All right. So now we know the meaning of this, right? Discrete type. This is discrete type. And for continuous type, the meaning is similar. As I said, the probability of some interval is the density function times the length of that interval. Because the interval is small. If the interval is large, they have a lot of different. But when this interval is small, then they are almost close. Then it's very close, almost the same. Yeah. So here, you just replace. You think this is the probability, right? This is density times dirt. This is density of x times dirt. Here, this is a density times dirt, right? This dx is a dirt. This is probability. Probability times the value, and do summation. The integral actually is a summation, right? The limit is a summation when you have a limit. The summation, limit of a summation, right? So these two actually similar meaning. Okay, so this is a mean. This is mean. Give us the average value. It's a mean value in the middle. It's kind of average, right? Kind of average. And we have second average value. It's a variance. Variance of random variable x, we denote it as VAR of x. That means variance of x. Variance of x. Variance of x, we still have two formulas. For discrete, or I can use one formula. Yeah, I just use E. Variance x, it is just E of x minus EX squared, like this. So no matter it's a continuous type or discrete type, we always have this. If it is a discrete type, then we can, if you want, you can write more. It will be in discrete type, this E is a summation. Okay? Discrete type, this E here is just summation. In continuous case, this will be integral. So if you want, you can write in this way. This is a E, so this is a summation of those xi minus EX. EX is a fixed number. Here you have to pay attention. EX, you have EX, you calculate by this way you get EX, or by this way you get EX. This EX, they are not random value. They are fixed value. They are not random. They are fixed value. Alright. So like here, you have 2 and 4. They are random because X might be 2, might be 4. But the mean value is 3. That is 3. That's a fixed number. It's just one number, 3. Right? It is not a random thing. It is not something uncertain or can change. It won't change. Just a 3, a fixed number. Fixed number. So here, this is the EX, that fixed number. Then take a square. This is the value. You need to take E of this value, right? E of this value. So you need times the probability. I use a PMF, the mass function, probability mass function. And for all xi's. Right. Then for continuous case, very similar. You change the summation to be integral, and xi, now it is just x minus ex squared. And here's the density function, not similar with the mass function. It's density function. It's fx of x, then dx. Here's from negative to positive infinite. That means all lowercase x, right? This lowercase x. This is a capital X. Alright. Yeah. So you can calculate by this one or by this one. So this is a variance. And what is a variance? What is the meaning of a variance? I use an example to explain it. Example. I have a random variable x has a PDF. Now I use a continuous one to be the example. Has a PDF fx of x equal to 1 or 0. 1 or 0. Here, if 0, okay, not 0. If x smaller than 1/2. Here's if x larger than 1/2. Okay, so it looks like this. Negative 1/2, positive 1/2. Here's 1. Suppose the random variable x has this as a density function. Then what is the variance? What is the variance? We can find the variance by this formula, right? By definition. But before that, you need to find the EX, expectation value. Then you find this one. Okay. So we want to know what is this. So first step, we need to find the EX. You have to find EX firstly. This one is the integral of x times fx of x dx from negative to positive infinite. This is x, right? Okay, then what is fx? We know it is 1 when x runs from negative half to positive half, right? For all the other x, it is 0. So we only need this part. Then this is what? This is x squared over 2, and x run from negative 1/2 to positive 1/2. This is a 1/2 squared over 2 minus negative 1/2 squared over 2, which is 0. Yeah, make sense? Actually, when you look at it here, this is a density function, right? You gave the density of the probability from negative to positive 2, right? So that means x can take value between negative half to positive half. So x, capital X, can take value from negative half to positive half. This is a kind of, you think it's a sample space, right? Sample space is from negative half to positive half. And the mean will be the middle, right? This is the middle. That is a 0. Yeah, here we get 0. No problem. And then we have the variance. What is the variance? Variance x. Variance of x. Variance of x is E of x minus ex, then square. Okay, this is a continuous type, right? Continuous type. So we use this one to calculate. It will be an integral of x minus ex. Actually, this is 0 in this case, right? And then I need fx of x dx. All right. Then what it is? We know this fx is similar. This value will be 0 or 1 for different x. When x is larger than or smaller than negative half or larger than positive half, it is 0. So this we only need an integral from negative to positive half. We only need this part. And this is x minus 0 squared. And this is just 1, dx. So it is just x squared. So this is x cubed over 3, and x run from negative 1/2 to positive 1/2. So it is 1/2 cubed over 3 minus negative 1/2 over cube over 3. So this is okay, I move 1/3 in front. So here will be 1/2 cube. 1/2 cube will be 1 over 8. And this is a negative 1/2, take a cube. So it's minus negative 1/8. Right? Cube, you will keep the sign. If square, this will be, after square, you will be positive. But the cube, you will go back to negative. So this is a 1/3 times 1/8 plus 1/8. So this is 1/3 times, this is 2/8, right? 2/8 is 1/4. So this is 1 over 12. Okay, we have variance value is 1/12. You can look at here. You think this is the meaning, right? This is different between x and the mean value. The mean value is the difference between this one and the mean value, and then you take the average. So this gives us a description about how well the signal close to the center, right? And okay, we can do a compare. We can try another one. Example, still a random variable has PDF similar with this, but now I say PDF f, I say this is y. Okay, random variable y equal to, now it's also 0, and here's 1/2. I use 1. So here's if x larger than 1. Here's if x smaller than 1. And here I need to put a number. I put number. Actually, I have to put the number 1/2. I have to put the number 1/2. Later I will explain why only one choice here. If you put different thing here, this one won't be a density function. Okay. All right. Suppose it has this one. Then what is the variance of x? What it is? This one we have. I still use the formula. I find if I want to solve it, first one you need to find the ex. Now ex, it is a continuous type, so it is x times fx of x dx from negative to positive infinite. And this density function only has value between positive and negative 1. You put the equal is fine. Then this is an integral from negative 1 to positive 1. X is still x. The density function now is 1/2 dx. So this is 1/2 times x squared over 2, and x run from negative 1 to positive 1. It is 1/4 times x squared. Now is 1 squared minus negative 1 squared. So this is what? This is 0. Right, we get 0. Okay, we still have 0. Sorry, I'm working on y. confused. It's y. Sorry about that. It's y. Alright. This should be y. It should be, okay, this is what we say. Y, alright. And this is y. I forgot. I said this is capital Y. Then I go back to use x. Should be y, alright. And then the variance is an integral. Now is a y minus e of y squared times the density function. Right, this is this one. And then I plug in the value. This one should be 1/2 when y has value between negative and positive 1. And y minus ey is 0. Right, we just have ey is 0. And density function is 1/2 dy. So this is, I move 1/2 in the front, and this is y squared. Take integral, there will be y cubed over 3. And y will run from -1 to 1. So this is a 1/6. Here's a 1 cubed minus -1 cubed. It is 1/6. 1 minus -1. So this is a 2, right? So I have 1 over 3. Okay, now let's compare y and x. Compare. The PDF this is a f(x) of x. Right. Here's 1. Here's 1/2. Here's a -1/2. And the other one is from 1 to -1 to 1. And here value is 1/2. This is fy of y. Alright, density. So here you should know capital X can have value between -1/2 and +1/2. And the capital Y can have value between -1 and 1. More wider, right? And the variance, then the mean. Ex is 0 and the Ey is also 0. Both are 0 mean. And the variance of x is 1 over 12. See, the variance of x is 1 over 12. And the variance of y is 1/3. You see, here y, this value will be between 1 and 1, right? More values. And x, its value were from -1/2 to +1/2, right? Has less values. Y has more values, more wider, more values, and larger variance. Right? It's 1/3. 1/3 is larger than the 1/12. Right? This is smaller. So you have more wider the possible values, and then you have larger variance. This variance give us the kind of value related with how to say. So in the x case, the value of x will be a value inside this small interval, right, close to the mean value, and y will have larger range possible values. So the variance also larger. Actually, the variance related with how wider that value can be. Yeah, if the value can change in a larger range, then the variance should be large. If the random value close to some value, always close to that value, then variance were small. Variance are very small. Okay. All right. So for these two values, okay, we have these two values, and beside these two values we have some other things. We have, let me see, I use second is variance, right? Second is variance. The third one we call the moment. Moment, M-E-N-T. Moment with order k. That is e of x to the k. K could be 1, 2, 3, where the first order moment is just ex. Is a mean. It's just the mean. It is just the mean, right? When k is 1, this is just x. You can also consider ex some power on it. And if you want to calculate it, we still have two ways. For discrete type case, it will be xk times xki times px of xi for all xi's. And for continuous case, it will be xk. This is a density function. The x here is run from negative to positive infinity. It's a moment. Yeah, when you have the PDF or when you have the probability mass function, you can just calculate according to these to find this moment. And the fourth one we call the central moment. You also consider order. It is e of x minus ex k, and k could be, actually we start from 2, 3, 4 and so on. So the second order central moment equal to it is just the variance of x, right? And if you want, you can also use k equal to 1. If k is 1, x minus ex, you take its package value, you get 0. So we already need this. All right. Okay. So far, I think the most calculation, the calculation we need to work are these several numbers. We can calculate to find the probability. This is basically, right? When you have a density function, or you have a CDF or a PMF, right? When you have these functions, you can find the probability. You base on the given function, you can find the probability. This is a basic calculation. And then we have some kind of, we can say it's kind of advanced calculation. We can find some values. One is the mean, one is the variance. These two we use a lot. These two numbers we use a lot. All right. Yeah, the formula is here. You just follow the formula, then you can have your result. And then we have some kind of generalized. You can think the generalized of these two. That is a variance. Variance go to central moment, and the mean go to moment. Right. This one related with mean, kind of generalized mean. Right. If k is 1, it is just mean. And this is a generalized variance. When k is 2, that is a variance. Right, variance. Yeah. So we have these 4 numbers we need to calculate. These kind of things. Yeah, I will give you some homework you can do practice. Here I have example with a continuous type, and for discrete type, similar. I have a mean, right? I have this one. I think I just gave a mean calculate, right? Do I? Do I have a mean? I have a mean, yeah. Oh, this one, yeah. This is a. I didn't give I already gave you a continuous case example. I think did I give you when I explain the mean? I have. Sorry, I can't find that paper. Okay, I have 5 more minutes. I can give another example. All right, discrete type example. I have x with a probability. X could be like a 1, 2, 3, 4, and the probability is 0.2, 0.3, 0.2, 0.3. All right. Then we want to find the EX and the variance of X. We want to know this. We want to know these two. Then you just follow the definition. You can have EX. That definition now is a discrete type. So there will be summation of every xi times the related probability for all xi's. Now what are the possible xi's? They are 1, 2, 3, 4. So it is 1 times the probability is 0.2, and 2 times the probability is 0.3, and 3 times the probability is another 0.2, and 4 times the probability, that is a 0.3. So this is the mean. You can have 0.2 plus 0.6 plus 0.6 plus 1.2. So this is okay. So this is another 1.2. So these two will be 2.4. 2.4 and another 0.2. So 2.6. So this is the mean value. You can think you have 1, 2, 3, 4. You have 4 possible values, and the mean is here. This is EX is here. It's not in the middle because the probabilities are not equal likely. If they are equal likely, this mean must be in the middle. Okay. And variance of X. Okay, I still do the calculation by summation, right? It's a summation for all xi. Here will be xi minus EX squared times the probability. Right? We have this one. Then this is we have all x is 1, 2, 3, 4, right? Or 1, 2, 3, 4. So it is 1 minus EX. EX is 2.6. 2.6 squared, and the probability for 1, the probability is 0.2. And second value is 2 minus the mean and the square times the probability is 3. And the third one value is 3 minus mean, take square, times the probability is 0.2, and 4 minus the mean square times the probability is 0.3. Alright, we need a lot of calculation. This kind of things will be easier if you use a computer, but here we can just let me finish it. Now it's 49. I have a few seconds only. Okay, this is 1 minus 0.6 is 1.6 squared times 0.2, and this is a 0.6 squared times 0.3. This is a 0.4 squared times 0.2. This is 1.4 squared times 0.3. Oh God, too much. Okay, I leave it here. Is all right? And we do not have more time. Time is over. So I just leave it here. If you are interested, you can finish calculate. Not a big deal, right? I just leave it here. Alright, that's all for today. See you next time.